Hi everyone, it's Maurice and welcome to Sunday afternoon coding. What we're gonna do today is we're gonna improve the way the arguments are passed to a process. So what we did in the last, or like actually in the first video, was we were passing arguments to the process, but actually the way we did that was through various syscalls. So we had a syscall where we can get the number of the arguments, and then we can get the actual arguments passing in a buffer. But that's not very cool. What we want to do is to already copy the arguments into the memory of the process so the process can actually access it directly. Similar to how Linux is doing this thing. Um, maybe I can show you maybe a quick drawing to make it more clear what I want to do. So basically, what we already have, like if this is memory and this is the top, so we have a higher address here, we have 0 here. So the layout of the process is like this, like we reserve a 4 kilobyte area for the stack. And at the moment, we're setting the stack pointer on top because the stack is growing downwards. And down here is various things like code, data, and so on. But what we could do is we use part of the stack for the arguments and just put the stack pointer a little bit lower. So what I imagine is what we're going to do is we put in the arguments. So for example, we have the name of the process. Um, then we have a null pointer. Like basically, I don't want to encode the length. I will just use basic C string. So we have the null pointer. Then we have the arg1, which maybe goes until here. Then we have a null byte, arg2, which goes up here, and a null byte. And then at the end, we have a single null byte, so we know we are at the end. And the new stack pointer will be pointing to here. And we pass in a pointer of the first argument to some register so the process can access it. And then the process can iterate through them and basically, yeah, iterate through all the arguments. That is the thing we're gonna do. With that, we save this additional syscalls, and yeah, it's a little bit cleaner. Okay, so in order to do that, we're gonna have to copy the arguments first in memory. So the sysexecute syscall already receives the arguments. So we're gonna go into that call. We start the program, we pass in the arguments, and then we create a process from the elf file. And I would say we pass in the args there, so the created process will already having the arguments, and we don't have to set them afterwards anymore. So let's receive the args here. And then I think it would be a good point, yeah, to put that in the elf loader, like what the elf loader is doing. It creates the page tables, it reads the elf file, it allocates a stack. So we could copy the stuff to the stack here. It maps the stack, and then it copies basically the data from the elf file into memory. And I feel like the loader is a good place to do that. So we're gonna pass the name and the args. We need the name as well because traditionally the first argument is the name of the program, or basically the, like if you have a symlink, it's the name of the symlink, like basically with what you call the program. And then we have to, set the register state to the corresponding stack start. So I guess we return the new stack start. So let's do that. Stack start is a usize. Stack start, and this will be stack start. And then we have to adjust this signature to the name, which will be a string slice, and the args, which will be a slice of string slices. Perfect. And yeah, what we are currently doing is we only allocate 4 kilobytes of stack, and I don't have any mechanism yet to grow the stack, and we're gonna keep it like that. So we're gonna count how many bytes we use with the name and with the args, and if they exceed 4 kilobyte, we will return an error. And yeah, that's basically what we're gonna do. Let's put that into a separate function to keep the loader function clean. Set up arguments. And what we're gonna get is the stack, which will be a reference to basically the data. We're gonna get the name, and we get the arguments. And we return the offset, like how much we need to decrease the stack pointer. And this will return an error in case the stack is not big enough. So let's quickly create an error enum. At the beginning of the operating system, I was not very good with error handling. I was just unwrapping everywhere, but now I'm a little bit better on that. So let's create a loader error, stack too small. We derive debug here. And this will be basically a result of usize or a loader error. And what we're gonna do here is, yeah, stack offset will be set up arguments. We get the stack. I have a thread for the pinned heap pages. So the pinned heap pages is basically just a wrapper around a box of a slice of pages. So you can allocate a continuous range of pages. And I have this trait here to extend that with a method to get the pinned heap pages as a slice to U8, but this trait was not public. Okay. That means what we're gonna do is set up arguments. We're doing stack as U8 slice, pass in the name the args, and actually we make this also a failable function. Loader error. So we get a stack offset, and so the new stack, how did I call this? Stack start will be stack start is the top address? No, stack end. Okay, so this is kind of other way around because the stack is growing downwards. Yeah, it depends what you define as end or start in this case. No, actually, stack start is fine. I think this should be usize max actually. So if we're gonna do hex plus page size is 49.6, -1. And how many are these? 16. So yeah, actually stack start is basically, I feel like we can do better here. Usize max, and then the stack end is depending. It's stack start minus page size. Not sure if I broke something here now. We will see. Do I need to subtract one? I don't think so, because this is already on the usize max. Okay, we will see. And yes, we have the stack start minus the stack offset. And then we need to align that down to basically 8 bytes. So I think I have an align down function somewhere in the utils. Value and alignment. Perfect. And then we can just return the stack start. And this will be a result. So we get an okay result back. Perfect. Now we need to copy the data into the stack. Okay, so let's first count the total bytes to see if we have enough space. So we have the name dot, I think len, is it like what happens? Yeah, this length is in bytes, not chars, because string can handle UTF-8, and in UTF-8 not every char is a byte, so that's fine for us. Plus the args iter like map length, and this summed up. But we still need to take the null bytes into consideration. Yeah, this will be a use size. Why? How is that's them and returns the result. And the primitive integer type is being returned. This method will panic if the blah blah blah. Because the len is returning in use size, so why? Can't it add up here? To be honest, it's the first time I'm using sum. I thought it would have been easier. Do I just need to say sum use size? Okay, whatever. Why can't the compiler figure it out? But that's okay. And we need to add 0 bytes into the account. That means we have total bytes plus 1 for the name plus args len and plus the last 0 byte. like 0-byte terminator, let's call it like that. Okay, if the total bytes we need larger than the stack, actually it's already, if it's the same amount, we cannot do anything good, so we will return the error. Exactly. And basically then we start to copy it. And how do I want to do that? So actually at the end, we're gonna return the total bytes we're using. And the stack is already, like the pin-t page, is already 0? Yeah, we allocate a 0 page. So this should be 0. And then I guess we want to have a slice for all the data we're gonna copy in. So we know the stack size is stack.len. Actually cannot move that up, so it's a little bit more readable. See. That function. And so the start offset will be the stack size minus the total bytes. And to be honest, it's easy to mess that up with like off by one error. So maybe we write a unit test for that function. We will see. Copy2 will be the stack from start offset to the end. And then we start first to copy the name. So copy from slice. They need to have the same length, but I have this utility function somewhere where I'm already casting that. Should be in. Is it in the kernel? Copy slice. Exactly. So we're doing first the copy slice, and the source will be name as bytes. Yes. And destination will be the copy2. Then we have to advance the offset. So let's say this is just an offset. So this taking the 0-byte into account. So now we can do for arc in arcs. Basically the same, except that we're doing arc. And the last 0-byte should be already okay. So let's assert that actually the offset is equals. It should be like we should have like 1 byte left in the buffer. So can we say stack offset should be 1? we should only have 1 byte left. Okay. Um, and actually we need a way to tell this stack offset to the process. Because, yeah, so let's do it a little bit different. Let's just say args start. So this will be the, actually, like we can do this as an, no, let's leave it as a usize. So the args start is the stack start minus the stack offset. So we have the arg start here, and where we call this will be the args start. And we actually also return the same type. Because we currently don't have any other errors, I will just use the loader error here. And we just pass that like this. Okay, so let's say in the A0, we put the args start, and the stack pointer will be pointing to a line down, args start, basically -1, like we want to go there 1 byte before, and have an alignment of 8. Sounds pretty good. Now we need to take the new method signature into account, and actually here it will be the init process, so we cannot like really fail better, and we don't pass any arguments, so this should be fine. What else? Oh, the whole tests should be fine. Yeah, actually, we should like make a test here for the process and then examine the stack. We might do that. So we can first test everything with a unit test, basically. So what else exactly? Where is this used? Only in the system call? Yeah, this should be like a result. Should do scheduler error. This will also be like just a loader error. No, not really. Will be a scheduler error because we also have the error type that the program doesn't exist, like the name is not known. So we can do this, and we need to define the scheduler error. Scheduler error, and it will be invalid program name, or we have the loader error, which will be just the loader error. And now we need to convert, the error type. Like if we return here the loader error, it should be converted into this type. And I have somewhere a macro for that. I'm not sure if it's like usable everywhere. Is it here in the definitions? Impl from validation error. Why can't we make that more? Yeah, we could do like from to, and this will be from to type from and then this will be the validation. Actually, I think expected. Can I do this? Do I need to do like these concat syntax? Where have I used that? Here, concat, and then so self from So we're taking the from validation error into self, which will be the to type. But apparently he doesn't want me to do that. Expected identifier. Can I convert? But we have two types, so yeah. Yeah, actually I want this concatenation. Doesn't this work like I want? Expected comma where? This is the thing, because we're writing everything ourselves, we don't have the, is it this error crate? Yeah, this error crate is like, it would give us these things automatically. So can I convert like Rust macro type to ident? Is that like possible? Yeah, but I want to convert it. Isn't that possible? So the string representation of whatever token is passed in. Can I? Stringify, can I do? Yeah, because I like, that's, we want to have this type. And like I could do it with like the name, but then it, No. Yeah, this would work, although I feel like it's not very nice. Can I use this? Probably not, right? Ooh. Yeah, cool. Okay, so let's just make the from trait an identifier, which is also a type, I guess. So, and we should export this macro. I have a macro, so oopsie, doop doop doop. Mm-hmm. And let's export it to the whole crate. Cool. We can import it here. Exactly, and then we can go ahead and say for this impl from, actually it has to be like a different name, impl from to, because I feel like we impl from the first type to the second type. So we say impl from to, import it, and then we say from the loader error for the scheduler error. So basically when we return a loader error, we convert it into this type. And this works. Wants to have a okay. We cannot convert. So what are we returning here? We return a loader error. And we should implement here from a loader error to a scheduler error. Should be doing this macro. Is it just an LSP issue? I cannot find this macro. Let's fix the import errors first. It should work like that. Oh yeah, nice, it works. So the start program returns. Nice. Okay, and here we can do something also similar to that, because now we have the macro. The PID, and if we get the PID, we are returning an okay PID. And we have to impl to the sys execute error. So where do we want to do that? Maybe here. From scheduler error to it's annoying because the sys execute error is defined in a common thread, and now we're in a kernel. I feel like I have to change this a bit because it feels annoying, but it feels super annoying because I want to have like types I am defining in the kernel to use them also. Okay, we are gonna replicate the scheduler error real quick. Where's the sys execute? No, here it is. Exactly. So we received the scheduler error. We have already the invalid program name. Oh, that's super annoying. Should I put the error types like scheduler error also in the comment thread? I mean, it would make sense so we can use them everywhere. Okay. I'm not sure if this is a good decision, but let's see. So actually we're going here to the errors thread and we're doing this here. We're doing that here. Restart the LSP. The LSP. Bam, bam, bam. We are basically implementing also these things here, the impl from two thingies. And actually, let's also like put all the other error types there as well. So we can have them all in one place. Let's move that down. It's nicer to have them all. Let's derive debug from them. Yeah, why are you complaining? Let's see, now we need to fix a lot of imports. This doesn't have to be like this. This was from the previous syscall interface. Okay, get the loader error. Get them here. Here as well. And now we can implement our from scheduler error to sys execute error. And the sys execute error needs a scheduler error type. And now it should work fine. I think it needs some time to realize that it's okay-ish. We get a scheduler error and we're converting that into a, let's see if we restart the LSP if it gets better. Looks. Now we need to import the error types here first. Actually, what we could do is, now let's put them one after another. Okay, we don't need that from two here. This has changed its location. We like This is, I cannot see anything. Yeah, that's a little bit just like cleaning up. But I feel like it's nice to have the errors types all up there so we can use them from everywhere. Because yeah, the user space also needs to have these type of errors. Yes, yes, yes. Okay, let's remove these unused imports. Okay, are we compiling? Indeed, we are compiling. So maybe let's first check with a unit test if the loader thingy gets right, or just see if the current unit tests still work. Actually, we can execute the whole, oopsie, test suite to see if we didn't mess up anything with the OS in general. Of course, we messed up. Um, Could it be that, okay, the page tables are complaining when we create a process from ELF. Is it because we set up the arguments right and we map the stack, but we still have, oh, I feel like we messed it up here. So the stack is like one before we reach the new boundary. Because, yeah, it looks better. The reason why it was complaining was that if we have the stack here, oh, I'm a terrible painter, and this is our 4 kilobyte area, then the stack end was pointing here to the next basically 4 kilobyte page, but we need to put it here. That's why you have to add one basically. And some are failing. Okay, we don't get any arguments anymore because we removed this call, but should we check for, yeah, let's do a quick unit test. So we already have the infrastructure. So what we do here is very much down, create process from ELF, mmap. But what we can do here is with args, arg1, arg2. And yeah, basically A0 points to the start of the arguments. So we have the process, the trap, register state, register A0. So this should be the start. So we can already cast that as a pointer to U8 and then let's create a C string. So there's core FFI. We have a C string, which is like a representation of a borrowed C string, which means like we don't have the bytes ourselves, but we have it somewhere else. And okay, from pointer, yes. Yep, that's exactly what we want. And that's unsafe, but we are here in unit tests, so let's do everything in unsafe. We are checking, like, unsafe is okay in unit tests because we are checking the behavior anyways. So this should be like the name of the argument, which will be proc1. So we are doing assert name. Does it work? Like assert equals? Can I dereference it like that? Maybe like this. Is there a way compare like what are the methods as pointer? ToString. Yep, let's do it like that. So we expect an UTF-8 string. Exactly, and then we're doing the same for arg1, arg2, and then the empty. So we should have arg1, we should have arg2, and then this should be empty. And we need to adjust the offsets every time, so it's not even start like arg pointer. Maybe let's do it like this. Exactly, and then we need to do the arg pointer punkt dot byte offset. What do we need? Wrapping. It's actually, yeah, we need to move it forwards. Yeah, and this will be name.len +1 for the 0 byte. And we have to do that for why? What does it complain? It's immutable. No, that's good. Bam, bam. And then we're done, and basically should have named them the same, but doesn't matter. It's cleaner a bit. Arc2. Okay, let's see if the unit test still succeed. That looks like a 0 pointer reference. Oh, sure. The address is, we need to translate that to kernel space first. Uh-huh. So what we can do is like, this is the arc pointer, and then we have in the process, the page table can translate a user space pointer to a kernel pointer, and this must succeed. translate user space pointer to kernel pointer. Let's see if we are more lucky now. Not really. Okay. So we get an empty string. Mhm. But we set the, so I guess that's a 0 byte. So let's actually print stuff out. What are we returning here? Like the total bytes we need. So yeah, this should be at the beginning, right? So the offset is the stack size minus the total bytes. Uh-huh. And then we add that, and actually, yeah, this will be, okay, we return the total bytes. So this is the total bytes. And we say stack start minus the total byte. Let's quickly verify, not that we are like off by one. I have to check why, but the arc start, where do we put it in the register? Yeah, arc start. Let's see if we're off by one. Okay, it looks better. Oh, could it be? Wait, we expect the proc1, but we get arc2 1. And what are we doing in the test again? Arc2 1. Mm, with the total stack size minus the total bytes we need, then we start at the offset and we're copying the name first. Oh, I see. Okay, we don't adjust the offset. So, okay, actually, I feel like this was okay, but we forget to adjust the offset. Can we just do like, not the copy to, but we're doing the stack offset. And then, yeah, we forgot to redo our offsets. Okay. No, not yet. Okay, was mm-hmm. Where did I add the total bytes here, right? Quickly turn on the lights. Okay, now okay, something. It's good that we are writing a unit test. So the name is proc1 and we're failing 342. Basically, oh, I think we should be fine. I forgot to adjust that. Still the question, why do we need to do that +1 there? Oh, very nice. Oh yeah, with total bytes. Hmm. Yeah, I guess when we just subtract the total bytes, we go again beneath the buffer. And yeah, this is always very much annoying, these off by one errors, but we will get there. So this will be stack start minus total bytes +1. We want to point into the arguments. Okay, so basically now we happily copy the arguments into the user space, and then we now need to have a way in the user space to retrieve these arguments. And that's what we're going to do now. So in the user space, the way the kernel calls this start function. So you see in if we create a new process, then we somewhere, or we get the entry address. Yeah. And, and the entry address is basically, I have a linker script for the user space, user space LD. Yeah, we say the underscore start is our entry method function. So that's what the kernel calls here. Then we call into the main function, which will be defined in the actual library. And then we empty exit with the status code exit. So what we do is we get the argument here. And the question is, do we want to pass it to the main function? Because in Rust, it's not passed into the main function. We basically we have an args function which returns a struct which implements an iterator, and I guess we do it the same way. Yeah. So, okay, what we gonna need to do is, should we do that in here? What else do we have? Util print panic. I guess we do a args rs mod args, and here on the right hand side in the args function we need to initialize the this pointer. Like we don't know when the program will call us to get this arg structure, so we need to save this value somewhere, otherwise it gets lost. That's why we'll do a static arg start, which will be a runtime initial. Let's restart the LSP. Like I have this type which is called runtime initialized, which is basically for that. So you can initialize it at runtime. Why do you complain? Is this a kernel thingy? Oh, it's in the kernel, so we need to transfer that into the common lib. Yeah, A bad thing is that I need to have the tests in the kernel, otherwise they are not executed, but yeah, we can deal with that. So we put that into the common crate. We can just, yeah, let's copy that from the kernel source klibc runtime initialize. Pub mod runtime initialized. We will copy the tests real quick, like we will do initialized kernel source test runtime initialized. That's where we put the test. No, I just want this block here. Yeah. And then basically we can remove the kernel source kernel libc runtime initialized. And then we need to adjust all the errors. So yeah, that's not there anymore. So import that from common. So again, a little bit of cleanup and, get things to the right spot. Yes. I hope the Helix editor gets a little bit like smarter about that in the future. I have more functions, or maybe it already has and I'm just not knowing it, but yeah, we will see. So I have to, yeah, there's a lot of runtime initialized data, and you will see how it works in a second. Yeah, it's also used for things which are not const yet, so I cannot construct them at compile time. Things where I need to allocate a vector, for example, for the process table. But yeah. Oh, and I need to make that visible, accessible to the test. This, yeah, I want to have like a better version for that. Should work out. This should be, no, it must be const. That's why, yeah, don't complain about it, please. Oh, this is now Clippy checking for the test. I updated the compiler recently. We're not gonna do it that now. So in the abstract, we have the runtime initial data of the pointer. And we have an init function. We have an init function which receives this pointer. And what it does is it sets, or it initializes argstart with the value. It says, yeah, okay, uppercase. Ah, yeah. because it's a static. And then we do args static. Oh, no, just init. And now we want to have the iterator, which will just keep like a pointer to the current arg. And we implement the iterator trait for args. And what we return is a static string because they will be in memory forever. Yeah, nice. And we have a function args, like the same way we have it in Rust. Yep. And it will return the args struct. And yeah, we don't need an initializer for that. Although, let's make it nice. Like this, and so we can return new from args start dereferenced. Very good. And now we need to implement basically the iterator, which will not be utterly complicated. So let's say we create the C string, which will be core FI C string from pointer self current. This will be unsafe. And we need to trust the kernel that this is a correct string. And then we convert it to Rust's to string type, and we do it and we need to trust that the kernel must give us only valid UTF-8 chars. And then we can put the current is, how have we done it with add? Yeah, unsigned pointer is basically string. Or can we just take the C string punct dot len? Actually, it's just clearer to just take it like this, plus the 0 byte. It's also unsafe, sure. And basically, when do we know we're done? It's basically when this pointer shows already to a 0. So yeah. If the string is empty, let's don't do anything. Authorize return this thingy. Well, nice. So let's try it out, I guess. Let's first remove the old syscalls, and then we see where it crashes. So we can just replace that. So this is all the code we don't need anymore. And the echo program, yeah, exactly. Has to get like get the args function. Do I have access to that? It's in the user space, so use user space args function. So exactly, and then we have, or we should have, a nice iterator. We don't need to get the buffer. We need the index though, so we know it's the first or the last argument. And this will be I see. Then let's do it other way around. So we don't print it at the end, but we print it at the beginning if we are greater than 0. Okay. That's why user space lib. You have to make that pub. Actually, I only want to make this function public as well. Destruct. Nice. So we have a lot of that code, but let's check that later. Let's run the test suite. And if this succeeds, we're already kind of done, I guess. Not exactly. Oh, yeah, right. So the first argument is the program name, and we don't want to have that, so we want to skip the first one. I'm not sure if the index is then should be still 0. No, we need to first skip it and then enumerate it. Let's see. And I guess some Miri tests will complain about this unit test. Oh, wow. Beautiful. Very beautiful. Let's remove all the old mess. Yeah, allow Clippy new without default because we have to have a const function because we're using that in some statics. We don't need this arguments in the process struct again because we were like saving them the arguments before in the kernel, but it's like not a cool way. So just remove that. Yeah, feels good to remove so much code. And this is just like some, yeah. So, yeah, we did a lot today. Let's see if Clippy is fine and Miri as well. I guess Miri not, like if in case you don't know Miri, Miri is a interpreter for the Rust language. And with that, you can find bugs in your unsafe code. And I'm using that as well to execute my unit tests, but sometimes it's a little bit problematic because Miri uses something called, what is it called again? provenance, which means like a pointer, like mostly people treat pointers just as integers, but actually they are more than integers. Like they should also like have some meta information about the object they're pointing to, so the compiler knows what's an out of bound access and whatnot. Long story short, we cannot just cast usizes to addresses, which we just did, and I guess that's where it fails here. Integer to pointer cast, but I guess we can just like let's see if we can fix it. Mm, maybe we can fix it. Um, because this arg's start will be returned from here. And yeah, not really much because it's like a virtual address. So maybe we need to deactivate this exposed provenance again. Because there is no, like it's not valid. I cannot tell Miri like, oh, this is like a pointer points to valid memory, although it just complained about my cast here. And if I don't, like, I can also say, what was it? Core pointer from like there was a function where I could just say to Miri, yeah, don't worry, I'm know what I'm doing. Converts an address back to a pointer, picking up without provenance. Exactly. Without provenance. And let's see where we fail now with Miri. So Miri is a lot slower than native execution because first the code has to be compiled and debugged. So Miri has all the information, and then it's just interpreted. So yeah, they take a little bit longer to execute, but it gives you more security. And now with exposed provenance are not supported. Maybe we can with exposed provenance pointer 19 core pointer with exposed provenance. Yeah, sorry, now we have to wait again for the execution. I will just try that for a couple of minutes, but then I will, yeah. Oh no, actually, it's part of the process. So let's see how far we can get here. So basically, yeah, you get some context. What I could do is so it's compatible with Miri. I can say, oh, convert this pointer to a usize and keep the provenance in the back of your head. And then when I translate the usize back to the pointer, I can say, oh yeah, use it with the previously exposed provenance. So why is this not supported? Doop, doop, doop. I thought this is exactly the functions I should use. with address, use strict provenance. Yeah, okay. Yes, we need to cast it. Yeah, with exposed provenance. I did that. How do we start Miri? I mean, I don't think this will help me much anyway, so yeah, I'm still unsure like how much it gives me or just how much pain it is to have that. Let's see. If the test is successful now, I might don't leave it like that. Huh. Okay, he doesn't know our pointer because it has no provenance. Okay, to be honest, we will leave it like that and just exclude this test from Miri. Um, yeah, I will think about it if we can make it work with Miri, but yeah. How did I exclude it? Was it not Miri or something? It just takes some time. So if I don't want to execute a test under Miri, this is just like two types of methods I have. Oh yeah, just config, not Miri. Yeah, we should be fine. I'm already gonna upload that to GitHub. See if I formatted everything. Yeah. Process arguments. Store them on the stack at startup. Store arguments of a process on the newly allocated stack and pass a pointer to it in the annual register. Oh yeah, maybe one thing I didn't like talked a lot. So using this extern C, we say we want the C calling convention, which says that the first argument is stored in the A0. That's why we stored the argument point into the A0 register, and then we can access it. Without that, we would have the Rust calling convention, which has not like specified which argument goes into which register. That's why we need to say extern C to do that. The arguments are stored as C strings such that we only need to provide the start of the arguments. The user space program can figure out the length and the number of arguments by itself. Oh, damn it, I committed on main, but that's not an issue. I will just quickly change the branch. Pass process args on stack. Let's quickly create a new merge request and see if all the checks are successful. So see if we forget something. This is all the errors. Yeah, I should have done that like in a separate commit, but I was lazy and did everything at once. But yeah, I'm fine with that. Looks good to me. Yeah, this is more clear now what I'm doing. We're doing a little bit more of error handling, which is good as well. Having the test. Yeah, like not executing it with Miri is still better than having no test at all. And yeah, we're writing basically to just raw memory, so Miri cannot help us anyways, because the writing happens with a string slice to the stack, so we don't overwrite memory, so that's fine. And basically we make sure that we have the correct structure. So basically I'm fine with that. Okay, sounds good. Let's see what the checks are doing. Nice. So I guess this was it with today's afternoon coding session. Yeah, that's because I committed on main. Now it should be fine again. Cool. Yep. Now we get the new error types. That's cool when they are nested. Nice. Okay, this was today's video, and I hope you enjoyed it. And I guess I see you next time. Bye.